Hello everyone, we're taking a look at the midpoint today. We're looking at midpoint and segment bisector as it relates to a segment, and then we're looking at the midpoint formula. So these notes are a little bit longer. I'll be splitting up the video into two parts. So if you are looking for the information regarding the midpoint formula, go to the video with the part 2. Here in part 1 we're looking at the concept of the midpoint and a segment bisector to get us started. Okay, so we're going to be looking at using the midpoint to find the lengths of segments. We're going to do a little bit of a construction with a segment bisector to find the midpoint, and we'll be using the midpoint formula to calculate a midpoint. And the more challenging problem is, starting with the midpoint, can we calculate a missing endpoint? And that's where we'll be ending up in part 2. Alright, so let's take a look at some of our terms. Here we're starting off with the midpoint itself. The midpoint divides a segment into two congruent segments. We learned about congruency in the previous section of notes. We use congruence when segments have the same characteristic, the same length, but we don't have a value. So let's represent that in a diagram. So in our geometric figure, let's draw ourselves a segment. I'll call this segment AB. And we want a midpoint, so we'll create another point in the middle, and here we're just eyeballing where we think that will be, and I'll call that point M. Now by itself, this is not enough to tell us that the point is really a midpoint. We need some symbols on the diagram, and we saw this yesterday. These little tick marks that show up are telling us that we don't have numbers to look at, we don't have values, but we do know that these two segments are going to be the same size. They will be congruent. So we would say segment AM is congruent with segment MB. So think, for example, if you're doing a really long road trip from New York all the way down to Florida. It's such a long road trip, you definitely have to stop. And you want to stop at the halfway point. You might want to know where that midpoint is so that you could take a break from your driving and give yourself a rest. I don't know what that midpoint is, but that's the concept, right? It's smack dab in the middle between the two endpoints. So let's look at some words here related to the concept of a midpoint. We're looking at this idea of bisect and then a segment bisector. To bisect an object means to divide it into two congruent parts. And that's kind of what we did here. To bisect, that's the verb. So think of it like you're taking some scissors and you're cutting a piece of string. You are splitting it into two parts, and the two parts have to be congruent. Maybe we know the length, maybe we don't, but the idea is that they will be the same size. All right. A segment bisector then is the object that is doing the cutting, the splitting. A segment bisector is an object. It can be a point, like what we diagrammed earlier, but it doesn't have to be a point. It can be a ray, a line, a segment, or even a plane that intersects the segment at its midpoint. So let's draw another figure, and this time we'll use something other than a point to show a segment being bisected. So once again, I'm returning back to segment AB. And now we want to create an object that is bisecting this figure. We'll do something other than a point. How about a ray, just for something different? Let's draw a ray. So I want to draw a ray that is going to cut, that is going to bisect this segment. So I'll put the end point of the ray out here, and then I'm going to draw the ray in such a way that it looks like it's going right through the midpoint. Something like that, perhaps. So we would say ray DM is the bisector of segment AB. So the bisector is the object. To bisect, that's the verb, that's the action that it is doing, and when we create that bisection, then it forms a midpoint. Alright, let's look at some examples on the next page here. Turning the page to the next side, you can see that in example 1 and 2, we'll be looking at some segments here with a bisector drawn. But before we get to that, let's think of a construction here. And we're going to use a piece of tracing paper to just kind of diagram what we'll be seeing in a moment here, creating our very own segment bisector. So I'm using this piece of tracing paper, and I'm going to draw on it a segment of some unknown length. Again, we're not using the ruler. We're just using the straight edge to create a figure. What we want to do is we want to figure out where in the world is that midpoint, and we're going to do that without any measuring. When we do a construction, there's no measuring at all. This walks you through the steps here. We created segments with endpoints A and B, so now we're going to fold that paper so one of those endpoints is on top of the other. And when we do that fold, what you now have are the two halves. One is layered on top of the other, and where the crease occurs, that crease is the segment bisector. So I'll create it as another segment. I'll call that segment CD. So that crease is the segment bisector. It is bisecting the original segment AB, and where they touch, that's the midpoint. And little tick marks on either side to indicate that. So with a simple fold, you can create a segment bisector, a midpoint, and those two congruent segments. That's what this construction is describing. So when you look at the diagram, you see here's the segment, and here are the tick marks on either side, and this segment VW, that's the segment bisector. So you're looking for these little tick marks in the diagram that tells you that we have congruent segments. So segment RT is the same size as segment ST. If they're the same size, they have to be the same length. So if segment RT is 21.7 units in length, then the other segment is also 21.7 units in length. They're asking us to find RS, so we would obviously just add them together. So to find the length of RS, we add together the two segments. Now this is the segment addition postulate we were learning about from the previous day, and so here we have a result of 43.4 units. We see something similar in this next diagram. It says find the length of segment AB. Notice there's no bar above the letters AB, so again we're talking about the length. When it says find AB, it doesn't mean find the figure AB, it says find the length of AB. So we want to add up these two pieces, and again you can see those tick marks on either side of point C indicate we have two congruent halves. So if AC is a length of 2 1/4, then length CB is also 2 1/4. So to find the length of AB, you'll add up 2 1/4 plus 2 1/4. So again, that's our segment addition postulate. Two small segments added together equal the large segment. So that gives us 4 2/4, which is 4 1/2. Those are basic values. Let's increase the challenge here by taking a look at example 2, because instead of numbers to work with, now we have expressions. The length from B to C is 3x minus 2. That's not just a value, that's an expression. The length from C to D is represented by 2x plus 3. Let's see how we would work this out. Again, they tell us point C is the midpoint of segment BD, and that's also confirmed by the tick marks that you see present in the diagram. And they're asking us to find the length of segment BC. They want to know how long is it from B to C. Alright, well, because we know that we have a midpoint, that means we know that the segment to the left of point C is the same size as the segment to the right of point C. That means the length of BC and the length of CD must be equal. They have to be equal because they are the same length because of the midpoint that exists. Alright, so let me use this column to the right to rewrite that statement and so we can get to our algebra. So because we know these are the same length, then BC is represented by 3x minus 2, and CD is represented by 2x plus 3. So we're going to solve for x, and then we'll plug it back in to find the missing length of segment BC. Alright, so let's go ahead and do that. I am going to start by moving my constant terms to the right-hand side. So we have 3x equals 2x plus 5. I'll move my terms with x to the left-hand side. So we get x equals 5. So again, that's not the final answer, but that's a key step so that we can then take that value and plug it back in. So the length of BC, which is represented by 3x minus 2, we're going to take that value of 5 and plug it in. So 3 times 5 and then minus 2 will give us a result of 13. There it is, our final answer. So let's do one more construction here in part 1 of these notes. Again, we're talking about this idea of a bisection of a segment, but this is a little bit more involved, and we're going to use a compass this time. So again, the concept here is we want to find the midpoint, but we're not allowed to measure with a ruler, because if we measure, well, then we have numbers, and then with numbers we can use the equal sign and we can use the equality. Instead, we want to be able to exactly identify where that midpoint is without measuring it, because again, in ancient Greece they didn't have rulers of that sort. So we're going to use a compass, and again, here's my compass that I'm using. I'll place the metal point at point A. And we're going to take this compass and we're going to create a span that's more than halfway. So you're just eyeballing where you think the midpoint would be placed, and then we just want to set the span so that's a little bit more than half. We're going to create 2 arcs. We could do 2 full circles, but the way this is placed on the page, we don't quite have enough room for a full circle. So we're doing an arc, which is just part of the circle. There we have a part of a circle, an arc drawn around the left end point. And now we'll create another one drawn around the right end point. And you should see these overlap up at the top as well as down below. So what we just did, we just walked through step 1 and step 2. We kept the arc the exact same span. We drew an arc from the left end point. We flipped it around. We drew an arc from the right end point. And if we had gone all the way around, we would have created a full circle. So think of it as 2 circles that are overlapping at the top and at the bottom. And because the span of the compass is exactly the same, then that means this distance is the same as this distance. In other words, they're equally distant from the endpoint. Again, down here where the 2 arcs overlap, this distance from point A is the same as this distance from point B, which means they're equally distant. And if you're equally distant from the endpoint, then that means it sounds like we can find the midpoint. We'll use our straight edge to line up these 2 points of intersection from the arcs. And where that vertical line crosses the original segment, that's the midpoint. So this vertical line then becomes our segment bisector. This is the bisector. We are bisecting segment AB, and there's the midpoint. So for our diagram, we're going to put those tick marks on either side to say segment AM and segment BM are the same size. So to finish it off, segment AM is congruent with segment MB. Alright, so this ends part 1. I'm going to turn the page over and then restart the video so that we can get part 2 with the midpoint formula on its own separate little video.